masterpiece of modern architects, where we are going to tackle the experimental stress analysis principles in this video, where engineering meets elegance. Yeah, this gleaming marvel not only graces the London skyline with its elegance, but also stands as a testament to the seamless integration of art and engineering. Today, we embark on a journey deep into its glass facade, unraveling the intricate dance of stress analysis principles that make this skyscraper a symbol of both beauty and strength. Mr. Otieno, I'll be taking you through the Shadi, located at the London Bridge Quarter. We shall start by understanding the Shadi glass, which incorporates the glass selection and the material itself. We look at the use of high-strength stuff and laminated layers of glass. And this is important because the tough glass materials, they help in withstanding heat rapidly when during cooling and contraction. And the stronger than regular glass end, they are shattered into small pieces. These glass materials are shattered into small pieces to ensure that they can be able to withstand heat. The lamination increases more strength of the glass, especially during wind movement. Yeah, we are also looking at the resistance against wind pressure because we know wind is high at the place. So we are looking at the wind load analysis, analyzing determining the pressure that is exerted on this building by the wind itself into different parts of the building. The high strength glass resists these forces, ensuring that the panels do not bow or break under high wind pressure because when this building penetrates deep into the sky. We're also looking at the aerodynamic design under the resistance against wind. We have to incorporate the aerodynamic principles, especially when wind rotates the building. We have to take the design into account. So those are one of the things that was taken into account during the analysis of this design. Yeah, lastly, the thermal stress analysis resistance, which is important, and this incorporates the low E coating and thermal stress analysis. The thermal stress, which is important. The thermal stress, the glass expands and contracts at different temperatures, so the engineers took into account that, and also the E coating is also applied to ensure heat absorption and reduce the difference between glass and thermal stresses so that the building does not collapse. The structural framework is important because we have to understand the load bearing capacity, especially from the upper glasses, and also wind, reduction of the stress concentration through the placement of nuts, the gaskets that are placed to ensure uniform stress distribution so that there is no stress at one point, and also the flexibility of the framework, as you can see from the video. It has to be flexible to accommodate some minor movements, when the wind blows, we have to accommodate those minor movements. And I'm happy that engineers took that into account. And this was done through the finite element analysis software, which is now able to have this design after drawing is taken into the software, and we are able to analyze these stresses in real time. And also through the regular inspection and the maintenance so that we can inspect any signs of defects or deformation that occurs to this the shady glass. Stress analysis, very important. We have analyzed the different stress conditions at different places. And we start the wind pressure analysis, which is an important concept that we have to look at, especially during the design of this building. Yeah, and the meticulous computational methods that were applied, the engineering principles to assess the impact of wind at various speeds and direction on different parts of the building. And this was done through the computational fluid dynamic analysis, where we are looking at simulating the airflow patterns around the building by inputting wind speed directions, the building dimensions, and to calculate the wind distribution of the load. We are also looking at the glass panel strength calculation. We have to calculate the glass panel, and we are doing using the finite element analysis software, a very powerful software that is able to help us to do that and to analyze these stresses in real time and understand how this building was built by the piano artist from Italy. Next, the reinforcement strategies, very important. We have to analyze all this, and they were well analyzed by the engineers when during the construction of this building, so that they can make sure that they create something that is not going to break. Stress principles, the thermal stresses, very important, and all these were done using the coefficient of thermal expansion technique, and also the expansion of joints design and the thermal stress analysis. All these were done using this real-time software so that it can be able to understand at different places where heat might cause problems, so that it is taken into account during the design period. Art and the engineering connection, you know, this building is marvelous, and you can actually see the art and the connection to the engineering, the visual elegance. You can just see the glass panel orientation. You can see the night illumination. It has different colors at night, the reflective surface and the transparency. You can actually see how it reflects within the surface. This effect is achieved through the strategic placement of glass panels, which acts as prism, reflecting light at different colors and during the different times of the day. You can see the collaborative between this art and engineering. You can just see how the building looks like, the kind of architect that and the engineering that was applied, the visionary design concepts, the innovative solutions were actually applied to this, and the material selection. We can actually, I applaud the render piano artist from Italy who actually was able to, who actually found the vision found in his counterparts in a meticulous engineering process from his team. And together, they came together and they were able to transform this concept from a dream to a reality, building the shadow where artistry and engineering brilliance stand as equal, shaping skyline and inspiring generations to come. In conclusion, we can actually say that Shadi stands at the heart of London. It's not just a skyscraper, of course, but a testimony of human inventiveness and the excellent engineering that came into play. The classes, the colors, its structure, the visual elegance. It shows the artistic vision and the rigorous engineering in the realm of architecture that was able to come together as a team, and they were able to bring this building into reality. Thank you. Subscribe and comment.